Good afternoon, everyone. I'm Nasima Begum from University of Asia Pacific, Bangladesh, and the title of my presentation is An Accumulator-Based Revocation in Delegatable Anonymous Credentials. Here is the outline of my presentation. At first, I'll go through the background and our contributions in this work. Recently, due to availability of internet, the internet-based services are getting popular day by day, where the authentication is needed. And ID-based authentication system is often used. In this system, the user sends his ID and password to the service provider. Then the service provider checks the correctness of the ID and password. But the problem is here the service provider can know what is the actual age or birth date in this case. So this is a kind of privacy problem. So as the user is sending his ID and attributes, so the service provider can trace the user profiles or the user behaviors by linking with his ID. Therefore, one of the solutions to this privacy problem is anonymous credential system, where without the ID, the user is authenticated anonymously based on the credential issued from the ID provider or the issuer. In anonymous credential system, attributes of user can be selectively disclosed, where the attributes are certified by the credential. As an extension, delegatable anonymous credential system was proposed. This system allows the owner of the credential to hierarchically delegate her credential to another entity. Only the identity of the root issuer is revealed for the verification. In delegatable anonymous credential system, nodes of the entities form a tree, and each link between the nodes is a delegation from the upper entity to the lower. And each bottom entities, in this case, for example, the entity 1 can anonymously prove that he or she has a credential which is delegated away from the root authority or root entity. Here, I will explain the chain of delegation process from the root credential authority or certificate authority to the user. With the delegatable credentials, a chain of delegation describes that a user ID or the public key and his attributes are certified from the root certificate authority via the certificate authorities certified by upper certificate authorities. Then the user can prove the chaining of his or her credential to the service provider to get access of a specific services. Now let us see what is revocation. When the proving capability of the credential of a user is revoked, then it is known as revocation of the credential. Revocation is necessary when the user leaves the group or when the account is banned or when the user misuse of his credential. However, due to anonymity, it is challenging to check the revocation process. There is a previously proposed revocable DAX system where term epoch is used and the level L-1 entity issues the non-revocation certificate or non-revocation credential at every epoch for each non-revoked user at every epoch time. Then the non-revoked user proves the ownership of the non-revocation credential in addition to the ordinary chaining credentials. But there is a problem in the revocable DAX system that is previously proposed. Here at every epoch, all the active users have to access the issuer to obtain the non-revocation credential during the epoch. Since lots of users can access the issuer at the beginning of each epoch, so the issuer is in a bottleneck problem. Therefore, the communication cost is also very high. Thus, in this work, we proposed an efficient revocable DAX system using an accumulator, where only a single accumulator of the revoked user list and the credential on the accumulator are published at every epoch. Thus, the bottleneck problem of the issuer is solved and the communication cost is also lower. Now let us see the delegation process in the original DAX system, where the root entity owns the key pair, where the public key, only the public key is published, and the level 1 entity generates the key pair and sends the public key and the attributes to the upper entity. Then the root or the level 0 entity signs the public key and the attributes and then return the signatures on them, which is the credential for the level 1 entity. Then stores the signature as her credentials. Here is the next level delegation phases from the level L-1 from the level 1 entity to the bottom entity, that is the user. Here, the upper entity owns the credentials from the further upper entities. The lower entity generates the key pair and sends the public key and the attributes to the upper entity. Then the upper entity signs the public key and the attributes and returns the signature and the upper credentials. Then stores them as her credentials. Finally, the bottom level entity, that is the user, owns the chain of credentials from the root entity. Protocol of the original DAX system, user can prove the chain of credentials using the non-interactive zero knowledge proofs. Here, every public keys of the entity except the root entity are hidden. The unnecessary attributes which are not needed during the proof are also kept hidden. And the user is remain anonymous in this proof protocol. Here only the chain of the credentials from the root and the necessary attributes can be proved. Now let me explain our proposed revocable DAX system. The main policy of our proposed method for revocable DAG is to use a cryptographic technique called accumulator to accumulate or compress multiple elements into one value so that it can be proved that it is not in the revocation list with one verification formula. Here the accumulator that we utilized in this work is the pairing based accumulator, and the set of revoked users IDs are accumulated into one value. Then the accumulator is published, and the non-revoked user proves that his ID is not included in the accumulated value. Now let us consider the public parameters G1, G2, or Gn, and consider the set revocation list as RL of the parameters of some indexes. Let us consider that the revocation list RL consists of public parameters G1, G7, and G14. Then the accumulated revocation list will be according to the formula, according to this formula, like here, the accumulated value of the revocation list will be the multiplication of these three public parameters indexes. Then the user can prove that his ID I is not belongs to this revocation list. That is there is no common value between the user ID and the revocation list. And for this proving, we need the verification accumulator verification relation, which we can see in this slide. Here, I is user ID and W means the witness value. Now let us see the delegation protocol in our proposed system. The delegate protocol is almost same of the original delegate protocol. However, our improved version is at the bottom level entity, that is at the user level, user side. Here the L minus here the level L minus 1 entity generates another key pair, that is CPK tilde L minus 1 and CSK tilde L minus 1 for the revocation purpose. The user has his ID I, and then thus public key for the revocation CPK tilde L minus 1, and the public and the user ID are added to the signed messages in the credentials. Now let me explain the revoke protocol of our proposed system. Here level L-1 entity generates the accumulator SCCT of the revoked user at epoch T. Then signs the accumulator and the epoch value using his secret key CSK tilde L-1. Then he publishes the accumulator value and the signature to the level L entity, that is to the user. So here is the proof protocol of our proposed system. In the proof protocol, the user can prove the chain of the credentials say in the same way of the original DAX system using the zero knowledge non-interactive zero knowledge proof. And the public keys except the public keys of the root entity, except the public keys of the root entity, the other public keys of other entity are remain hidden. and the unnecessary attributes are also hidden, and the user remain anonymous. And the chain of credentials from the root entity with necessary attributes can be proved. Additionally, in our proposed system, the user can prove non-revocation using the non-interactive zero knowledge proofs. And the user can also check that his ID I not belongs to the accumulated value by proving the accumulator verification formula. Then the signature of the verification of accumulator is also can be proved. This is for the protection of the accumulated value. And also the user remains anonymous in this process. So in our proposed system, during the proof protocol, in addition with the chain of credential, the user can also prove non-revocation of his ID to the service provider or the verifier. Now I will show the efficiency of our proposed system. In the existing revocable DAX system, the non-revocation authority has to issue non-revocation credential to all the non-revoked users at every epoch. Thus, the central revocation authority, that is level L-1 entity, is in a bottleneck problem. Therefore, in our system, in our proposed system, our revoke protocol, the level N-1 entity publishes only an accumulator of the revoked user list and its signature only. Thus, there is no bottleneck and the communication cost is very low. However, since the prover or the user needs to prove accumulator verification and the signature of the accumulator verification, so the proof cost increases, which we consider as a trade-off. Finally, I will conclude my presentation. So in this paper, we proposed an efficient revocable DAX system using an accumulator to solve the bottleneck problem of the revocation authority. In the proposed system, only an accumulator and the signature of the accumulator are published. So this technique reduces the solve the problem of the issuer. However, the proof cost increases a bit, which we shall consider as a trade-off. So as our future work, we shall implement our system and performance, evaluate the performance, and to improve the, we shall also consider to improve the proof cost of the proof protocol and apply our system to permission blockchain-based applications. Thank you all.